Alright, welcome to my YouTube channel, and today I'm going to be looking at components of lipopolysaccharide. So I'll be looking at the components, the parts, the structure of lipopolysaccharide. Then in our next video, we'll look at the synthesis of lipopolysaccharide. Now, lipopolysaccharide is an integral part of the cell wall of gram-negative bacteria. Have you ever asked yourself, why is it that gram-negative bacteria like E. coli, they are more dangerous, they are more toxic than gram-positive bacteria? Now, the reason is simple. The reason is found in their cell wall. Gram-negative bacteria have a double cell wall, so a double membrane layer, while gram-positive bacteria, they have single membrane. Now, the components of the lipopolysaccharide is found in this outer membrane. Now, this is how the cell wall, the cells of gram-negative bacteria is. Here we have the cytoplasm. Here we have the inner membrane. Here we have the outer membrane. And here we have the periplasmic space, or you call it periplasm. Now, this lipopolysaccharide is on the surface of the outer membrane. That is where our lipopolysaccharide is attached, on the surface of the outer membrane of the gram-negative bacteria. Alright, and that is what is responsible for their endotoxicity. And if you are taking an antibacterial drug, it is this lipopolysaccharide on this outer membrane that will prevent the antibacterial drug from getting into the bacterial cell. So as you are taking it, lipopolysaccharide is chasing the antibacterial drug, so the bacteria is safe, it's not harmed. If there is environmental stress, lipopolysaccharide will chase it out also, making the bacteria safe. So let's look at the components of this lipopolysaccharide. The lipopolysaccharide have three main components. We have lipid A, we have core oligosaccharide, and we have the O antigen. Now, I'll use this diagram here to explain that. Let's assume this is our outer membrane. This is the outer membrane of the gram-negative bacteria. This is the inner membrane. And this is remember, the space between the outer and the inner is called the periplasmic space, or the periplasm. Now, lipid A is fused into the outer membrane. So the lipid A is actually a hydrophobic region, because this is fatty acid chain. Fatty acid chain. And you know that fatty acids are not water soluble, right? They are not water loving. So we say they are hydrophobic. So the hydrophobic phase are fused into the outer layer. And this lipid A here is what is responsible for that toxicity, the toxic property of lipopolysaccharide. So out of these three components, what is actually responsible for the toxicity of lipopolysaccharide is lipid A. Then, attached to lipid A, we have a core oligosaccharide. Oligosaccharide meaning we have few sugar units. So few sugar units are attached together to form. So this portion here is our core oligosaccharide. It's in the core. It's in between the two. Now, the oligosaccharide layer is responsible for the integrity of the lipopolysaccharide. So it helps in maintaining the integrity of the lipopolysaccharide. Then attached to the core oligosaccharide is our O antigen. This O antigen here is attached to the core oligosaccharide, and it is responsible for the specificity of the lipopolysaccharide. It's responsible for the diversity of the bacteria. So these are the basic components. Please take note, we have just three: lipid A, core oligosaccharide, and O antigen. So these are the three components of the lipopolysaccharide. In our next video, we are going to look at how we are to synthesize this lipopolysaccharide, because in exam you can be asked to write on the synthesis of lipopolysaccharide. So how will you do that? In our next video, we'll see that out.